Alright, we've got number 57 here, got an 8-sided die, each side having a different one of the digits 1 through 8. He rolls the die twice and writes down the order, or writes the numbers down in order. The results form a 2-digit prime. What is the probability that his 2-digit number is prime? Or a 2-digit number is prime? Express your answer as a common fraction. So we already worked through this one, or I already worked through this one. We're kind of doing it again with a cleaner video. Remember, with probabilities, right? Oop. Right? It's a fraction with the top being the outcome, or the numerator being the outcome, and the bottom being the total number of outcomes, right? Or total number of possibilities. And in this case, we've got 2-digit numbers made up of the digits 1, 2, 3, 4, 5, 6, 7, and 8. And when we write out those possibles, right, those possible numbers, we've got 11, 12, 13, 14, 15, 16, 17, 18, right? And we do 21, 22, ... 28, right? And there's 8 possible here, 8 here, right? And we could go down, and it will be 8 rows of 8, so 8 times 8 equals 64. So we know there's 64 total possibilities, and let's find out how many of these are prime. So that's going to be equal to something over 64. We just have to figure out how many of these are prime. And if we knew that off the top of our head, great. But if not, probably the easiest thing to do is to just write the table out, right? We'll write out all of the possibilities. 21, 22, 23, 24, 25, 26, 27, 28. But then let's save ourselves a little bit of time, because we know that not prime, right, are these rows, right? This has a factor of 2, this is a factor of 2, 5, a factor of 2, and a factor of 2. So we know that all of those numbers in those columns are not prime. 31, 33, 35, 37. We can actually erase 35, remember? Because that row is not prime. 41, 43. We're just saving ourselves some time here. Even though all of the other numbers are possible, we're just looking for the primes at this point. And now it's just a matter of going through and finding the primes. And I know that 11's prime, 13's prime, and 17's prime. I know that 21 is not prime, 23 is prime, and 27 is not prime. 31 is prime, 33 is not prime. In fact, any of the numbers on this diagonal would not be prime, because the factor of 11. And I know that 37 is prime. I know that 41 is prime. There we go. 43 is prime. 47 is prime. 51 is not prime. That's 3 times 17. 53 is prime. 57 is not prime, because that's 3 times 19. I don't like that stray mark, so we'll get rid of that. 61 is prime. 63 is not prime. 67 is prime. 71 is prime. 73 is prime. 77 is not prime, that's 11 times 7. 81 is not prime, that's 9 times 9. 83 is prime. 87 is not prime, that is 29 times 3. So let's count them up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've got 15 primes out of 64, so that is the probability.